Building a house isn't just about stacking materials. It's about turning an empty lot into a comfortable, efficient home that's built to last decades, all while delivering maximum thermal performance, protection against moisture, and a price tag that actually fits your budget. In this video, you'll follow the complete step-by-step assembly of a high-efficiency, low-cost house. We go from the very first foundation line all the way to the last screw on the roof, showing a construction system that's different from anything you've seen on the channel before. Stick around until the end to see how every single decision on the job, from the ground up to the roof, connects to create a strong, tightly sealed structure ready to handle sun, rain, and wild temperature swings.
It all starts with separation. The first battle of any house is against moisture rising from the ground. Here, the foundation piles are already in place, topped with metal brackets. The goal now is to create a skeleton of treated timber that will serve as the cradle for the entire house. Notice the positioning of the beams. It's not enough to just rest them. They must be mechanically locked into the metal brackets on the piles. This forms the perimeter of the base. It's a job that demands precision, because any out-of-square error here will multiply exponentially once the walls go up. With the perimeter beam system locked in place, we move on to the panel technology. There won't be a cold concrete subfloor. Structural insulated panels, or SIPs, are being installed. They are lightweight, yet incredibly rigid. The secret to installation lies in the chemical sealing. Before each panel is lowered, a continuous bead of expanding foam is applied along the beams. This foam does two things. It glues the panel to the structure, preventing future creaking, and creates an airtight seal. This is the principle of airtightness, starting from the bottom up. The fit requires force. The male-female joints of the floor panels must be hammered home with sledgehammers, always protecting the edge with a wood block to ensure there are no gaps. As the work progresses, foam is applied to the sides of each panel before sliding the next one against it. This turns the floor into a single continuous thermal slab with no temperature leakage points. To finish the platform, the edges are trimmed. Excess material is cut with a circular saw to align perfectly with the perimeter beam. Then the sides are closed with treated boards, screwed through the wood into the panel structure, enclosing the foam and protecting the insulated core.
If you haven't subscribed yet, now's the perfect time. Hit that subscribe button and drop a like. That lets us know you love this kind of content and keeps us pumping out more videos that actually make a difference. Your support is what helps the channel grow. Now we have a floating wooden floor, insulated and ready to receive the walls. Raising the external walls. Before raising any wall, the layout must be marked on the floor. Installing the bottom plate is critical. It is set on a bed of foam to prevent infiltration from underneath the wall.
Lifting the first panel is the moment of greatest vulnerability. It won't stand on its own. The panel was prepped on the ground. The connecting spline was inserted and stapled. It needs immediate stability once lifted. The solution is to form the corner as quickly as possible. The second panel is positioned perpendicularly, creating an L. This geometric interlocking is what gives the house its initial rigidity. At this stage, the most important tool isn't the hammer, it's the level. Making sure this corner is perfectly plumb is non-negotiable. If it starts crooked, the roof won't fit up top. Wall expansion follows an almost industrial rhythm. Apply foam to the side, bring the panel, fit it into the bottom plate, and use the sledgehammer, always protecting the edge with a wood block, to force a hermetic seal. Notice that a closed box is being built. Even when daylight runs out, the work continues. Window openings are predefined in the panel layout, eliminating the need for on-site cutting. The panels are assembled directly with the window spaces already in place. While the external walls armor the house, the internal walls organize the space. The SIP panel system was switched to traditional wood framing for the interiors. It's lighter, cheaper, and makes running plumbing and wiring much easier. The logic is on-site prefabrication. Studs and tracks are cut on the ground, and the frames are assembled lying flat on the platform. Using a speed square is essential to keep every stud aligned. Notice the detail of manual adjustment. Sometimes natural wood requires a little axe trimming for a perfect fit. Construction is precision, but it's also adaptation. Before raising, they check the diagonals with a tape measure. If the diagonals match, the frame is square. Raising internal walls is fast. A crew lifts the frame and immediately secures it to the external walls and anchors it to the floor. the house starts to gain rooms. But a wall doesn't just divide, it also supports. Working balanced on top of the walls, the carpenters install the top tie beam, ring beam. This connects all internal and external walls into a single rigid diaphragm. A generous amount of foam is applied to the top of the SIP walls before setting the tie beams, ensuring the airtight envelope remains intact all the way to the ceiling. They reach the top. To close the box, horizontal SIP panels are used to create a flat ceiling that also serves as upper thermal insulation. The process mirrors the floor, except gravity is now working against them. The main beams, much heavier, are prepared on the ground with precise notches, and then hoisted into place. The ceiling panels are laid on top. Sealing here is critical. Warm air rises, and any gap in the ceiling means energy loss. That's why applying foam at every joint and using high-torque structural screws is non-negotiable. After covering the entire area, fascia boards are installed around the full perimeter. This provides the initial finish and protects the polystyrene core of the panels. But the most impressive detail happens at night, from inside. With the structure closed, a total seal is performed. Every wall-to-ceiling junction receives expanding foam. The goal is to make the house airtight, like an upside-down submarine. At this point, they have a flat ceiling, but they need a pitched roof to shed water and create the desired aesthetics. To achieve this, counterbattens are installed over the flat ceiling to create an air gap, an essential ventilation space.
With the timber structure complete, the gable ends, the side triangles, need to be closed with OSB. Again, the technique is to cover everything and cut the windows afterward, this time using a chainsaw to find the structural frame behind the sheet. Now the final protection before the tiles, the breathable waterproof membrane. The gray underlayment is rolled out over the rafters. It blocks liquid water but lets vapor escape from inside the structure, preventing wood rot. The membrane is held with vertical counterbattens that also create the roof ventilation channel.
The wood is protected, but it needs its final armor. Work starts at the roof. Beams are used as rails to slide the large metal roof sheets to the top without denting them. Fastening is done with self-drilling screws into the purlins. The golden detail is at the ridge. Before installing the final metal ridge cap, a ventilated sealing tape is applied. It keeps insects and snow out while letting hot attic air escape. Only then is the metal ridge cap screwed down. Down at ground level, there's a vulnerable spot, the space under the house. That skirt needs to be closed. Horizontal boards and natural stone look panels are installed. This isn't just aesthetic. It protects the floor insulation from pests and cold winds. Finally, the wall cladding. White corner trims and starter strips at the base are installed first. Vinyl siding is clicked piece by piece in a system that hides the fasteners and allows for thermal expansion. PVC windows are set into the prepared openings, leveled with shims, and sealed all around with expanding foam.
Look at this structure. It started with piles driven into the mud, and now we have a passive house protected by multiple layers of modern building technology. This build went through every stage: foundation, SIP structure, internal framing, complex roof design, and fine exterior finishing. Every screw, every bead of foam, and every saw cut had a purpose: to create a shelter that requires minimal maintenance and delivers maximum comfort. And this is the final result: a safe, cozy home built at a low cost. That's it for today's video. Thank you for watching all the way to the end. See you in the next one.